Okay, welcome back to Algebra 1 class. I made another video faux pas as I recorded this video and the camera that I'm recording split it into two videos and I imported them, but I don't know where they went when I imported them. So I found the last half of this video, but I've not found the first half. So I went ahead and I'm going to rework some of the ones from the first half so that I can mesh the two videos together. So this video is probably going to look a little stupid. I apologize for that. The next video comes in halfway in on this problem, and these might not be the exact problems on the other one, but I wanted to go ahead and get these on here in case I can't find whatever I did with the other video. I am learning so that I could get this content out before I leave today. So we are on page 281, simplification of radicals, or pulling out like perfect squares out of radicals. So most times when you do roots, this is a square root. We don't write the 2 because that's a square root symbol. But most of the time we've dealt with them so far, they've been perfect squares. The square root of 36 is 6. That problem is done. I don't need to do anything else, okay? But when I get to a problem like 27, there is not a perfect square root of 27. 5 times 5 is 25, and 6 times 6 is 36, and it falls in between there, okay? So what I can do is break this down into factors that multiply to 27. I will break this down into 3 times 9, because that's the only thing that multiplies to get 27. And 3 times 9 is still 27, so it's still the same thing, but 9 has a perfect square, and since I'm dealing with a square root, I can take the square root of 9, which is 3, and bring it to the outside, and whatever number's out here, it multiplies. There's a 1 there, so that is a 3. And then this one has to stay, so my answer is just 3 radical 3, and that is the gist of what we're doing today, basically simplifying the radicals as best we can, and that's the way that you do it. Of course, they do get harder. When you're not dealing with a square root, you pay attention to the number up here, and it's going to tell you if it is a cube root or a fifth root or what, and that's what you need to deal with. All right. So this is a cube root. I'm familiar with a few of the cubes. So if I write a list of cubes, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64, I think. So right off the bat, if I want to break this down into a multiple, I need to see if any of these numbers are going to go in there so that I can pull a root out. Well, I know that 8 times 5 is 40, and there is a cube root of 8 because it's written right here. The cube root of 8 is 2. That 2 comes outside here, and my answer is left with 2 times the cube root of 5, and 5 is prime, so nothing is going to come out of that one. I can leave it alone. All right. So I go down to problem 20, and I pick this one because there's actual number on the outside so you can see that multiplication. This is not a cube root, it is a square root, so 8 is not going to work for me here because it's not a perfect square. However, I know that 4 times 10 makes 40, okay? So there's a square root of 4, that's a 2. It comes out here and it gets multiplied here. So 2 times 5 is 10, and I have a 10 left in there. Can I break it down any further? The only thing I can multiply to get 10 is 2 and 5. None of them are a perfect square, so this is the answer, and I'll leave it alone. All right. All right, this part of the video, the next part of the video, I was working on doing the letters and the exponents. So for right now, we're going to focus on the 64, and hopefully I can get them to connect decent if I don't find that other video, which I've had no luck thus far. So well, what we're going to do, this is a fifth root. All right, if you don't know what fifth roots are, and I don't know them myself, I don't memorize them, you can use your calculator and use the button that looks like this if you have it, which means you can put any exponent you want in there. So if I write the first couple fifth roots, you won't need to go far because they'll be pretty big, and I hit 2 in that button and 5, I'm going to get the first one is 32, and then 3 to the fifth root is 243. That's a giant jump. And 4 to the fifth root is 1024. So I'm not going to go any farther because that's 64. So when I break this number down, it needs to be one of these. 32 is the only option I got if it'll go in there. If it can't, it wouldn't be able to be broken down, but it can. That would be 32 times 2. Okay, and I'm going to leave the letters out for a second. The fifth root of 32 is right here. It's a 2. So this 2 comes out. Remember, you're doing fifth root. 2 times 2. That makes a 4. And this 2 has to stay in, so I'm leaving that 2. Division. All right, you want these to be multiples of whatever root is out there. So on Q12, all right, if you look right here, I could break that up into Q10 times Q2. Why? Because you say 10 times 2 is 20, not 12. When you multiply things with exponents, you add the exponent. So 10 plus 2 is 12. So this and this is the same thing. Why did I break it up like that? Because 5 goes into 10 2 times. Okay, so let me scoot this 4 over because I need the space when I pull my letters out. Alright, so if 5 goes into 10 2 times, that means Q squared comes out and that one's gone. But this Q2 that 5 won't go into has to come inside. Alright, if the R16, if I'm going to break it down, I'm going to go R15 times R1. Why? Because 15 plus 1 makes 16. Alright, 5 goes into 15 3 times. That means R to the third comes out here. That is gone, and R to the first power, you do not have to write that 1, you can if you want to, comes in, and this is your final answer. Okay? So I'm trying to be slow and baby step that for you, and I will show you again in this problem. Make sure you have that written down. I guess pause it if you need to, because I'm going to erase that and use this area to work on this problem. I don't know what everybody's been doing since they've pretty much been stuck at home. I was kind of getting bored and stir crazy until they told us we can come in and start figuring out how to convert y'all's classes to online. And now I got a whole list of videos that I need to make, so I'm not bored at all. I also signed up for a free college class that JCC was offering to kill time before I knew I was coming back to work. So now I have that, and I spent about 3 hours yesterday working on some of my homework for this week, and I still have 2 more assignments to do. So thankfully I am a lot busier than I was, so I'm not bored, and maybe after a week or 2 I'll get the hang of these YouTube videos and be able to edit some of them and figure out something with lighting. Somebody told me that I could use floodlights that maybe I could get at Lowe's, so maybe one day this weekend I might try to stand in line at the Lowe's, because apparently you have to do that, and get some lights to see if I can't get the glare off and get this video a little better. So 29 is the last one I'm going to show you. I hope that color comes through. Let me see. Okay. It is a cube root, and I have some written right here. I didn't erase those. It is a cube root, and we also have letters. So it's the same thing that we just did, and it should be easier because it's not a fifth root, it's a cube root. I have 54, all right? I need to know if 8, 27, and 64, obviously 64 is not going, but if 8 or 27 go in there, if the bigger one goes in there, then I definitely want to use that. If I use the smaller one, I'll have to do it twice, and I'll show you both ways, okay? 27 goes in there twice, I know that. But if I didn't, I'd have to use my calculator, okay? So I could work this and do 27 times 2. Okay, does 8 go into 54? You know, that's the most common missed multiplication. That is 7 times 8 is 56, not 54, but 9 times, what is it, 9 times 6 and 8 times 7, that's the most commonly messed up multiplication table in there, but 8 does not go in there. But I will show you an example of a problem if you don't get the higher one here in a minute. What do you do? How do you keep adding to it? But so far I'm just going to do the numbers, and there is a cube root of 27. If I look over here, it's 3, so I'm going to pull that out, and that gets multiplied out here. So 3 times 3 is 9, and then I have the cube root of 2 left in there. Okay, now I need to do my letters. Now this is a squared, there's no way I can get a multiple of 3 out of that because it's a squared, so that's staying inside. I can't pull anything out. This one's already a 6, 3 goes into 6 2 times, so I don't know why I don't leave no space there. Y squared, because 6 divided by 3 is 2, comes out, and that one's gone. Now z to the 5th, I could break down into z third and z squared, because 3 plus 2 is 5. Remember, you have to add the exponents here. And then 3 goes into 3 one time, so there's a z that comes out. You can write the 1 out here, exponent, you don't have to. That's gone, and z squared stays the same. Okay, so what happens if you don't pull the biggest one out? And let me think of a number that I could use that commonly would have 2 of them in it. Let's see. Let's see, I don't know if this one works, but say I have the square root of 48, and there's no perfect square root of 48, but I know 4 is going to go in there. 4 times 12 is 48, okay? And 4 has a square root, so I pull that 2 out. It gets multiplied by the 1 out here, so I'll have 2 root 12. However, 12 can be broken down into 4 times 3, so I did not pick the biggest number that I should have out of there. 16, I think, is the bigger number. I think 16 goes in there 3 times. So what I do is I'd have to separate it again. And again, I have 4 times 3, so the square root of 4 is 2. It comes to the outside and gets multiplied. So I would have a 4 and a radical 3 there. Okay, so you would just keep doing it until it's all the way reduced. If I did this correctly and did 16 times 3, the square root of 16 is 4. I pull that out here, so I have 4 radical 3, and you can see they match. Okay, so just because you don't pull the biggest multiple out doesn't mean that you're stuck and you have to start over. You can just continue on and reduce. All right, thanks for watching. Have a blessed day.